Welcome back, ladies and gentlemen, to sqadia.com. My name is Osama, and today we are talking about statistical tests. And in this specific lecture, we're going to talk about non-parametric tests of significance, in which we're going to talk about Mann-Whitney U-test, Wilcoxon signed rank test, and Kruskal-Wallis Ash test. As well as we already discussed in the previous lecture about parametric and non-parametric comparison. So we use non-parametric tests when the data is not normally distributed and when the assumptions for the parametric tests are not met. So in the previous lecture, we already talked about independent t-test, paired t-test, and ANOVA. And when the assumptions for these tests cannot be met and the data is not normally distributed, then we can use these tests as a substitute, which are Wilcoxon rank sum test or Mann-Whitney U-test for independent t-test, Wilcoxon signed rank test for paired t-test, and Kruskal-Wallis test for one-way ANOVA. So let's start off with Mann-Whitney U-test, which is actually a comparable test for the independent t-test. And once again, it is used to compare differences between two independent groups when the dependent variable is either ordinal or continuous but not normally distributed. So the ordinal option was not there in the independent t-test, but Mann-Whitney U-test can also be used when the dependent variable is ordinal or discrete. So often considered the non-parametric alternative to independent t-test, although this is not always the case. And what are the assumptions for Mann-Whitney U-test? Number one is the dependent variable should be measured at ordinal or continuous level. Assumption number two, independent variable should consist of two categorical independent groups, which mean two categories, for example, group A and group B, or a control group or experimental group, and so on. Assumption number three, independence of observation, which means that there is no relationship between observations in each group, which is similar assumption which was there for independent t-test. And assumption number four, a Mann-Whitney U-test can be used when two variables are not normally distributed, but for independent t-test, it was mandatory that the normal distribution should have been there. So how to apply Mann-Whitney U-test? Click on the non-parametric test, go to the legacy dialogues and click on the two independent samples. And then here this window would appear. Select the continuous variable and put it in the test variable, and select the categorical variable into the grouping variable, and then define the groups by giving 1 and 2. After clicking OK and proceed, then you would get these windows, and here you can see that here you have the mean values as well as standard deviation, minimum, maximum, and percentiles. You also get the mean ranks, because mean ranks are the thing on which the Mann-Whitney U-test actually gives you the p-value based upon. So here you can see that Mann-Whitney U p-value is 0.014, which means it is less than 0.05, which means there is a significant difference between the two groups. Now, Wilcoxon signed rank test is similar to paired t-test, but it is a non-parametric alternative to that, and it does not assume normality in the data, so it can be used when this assumption has been violated and the dependent t-test or paired t-test is inappropriate and cannot be used. So what are the assumptions for Wilcoxon? Number one is dependent variable should be measured at the ordinal or continuous, but for paired t-test it should be only continuous. And for assumption number two is independent variable should consist of two categorical related groups or matched pairs, such as baseline and follow-up or pre and post analysis type of studies. And in assumption number three, distribution of the differences between two related groups need to be symmetrical in shape. If distribution of differences is symmetrically shaped, you can analyze your study using the Wilcoxon signed rank test. So how to apply this test? Click on the non-parametric test, go to the legacy dialogues and two related samples for Wilcoxon signed rank test, and then put, for example, pre and post scores in variable 1 and variable 2 window, and select the Wilcoxon, click on OK, and you will get these windows. Here you have mean, standard deviation, and percentiles. Here you have mean, rank, and sum of ranks, and once again it is analyzed on rank. So here you can see that mean ranks are 8 and 8, which are pretty much the same, and mean value is also pretty much the same. So here you can see that the p-value is 0.07, which is greater than 0.05, which means that there is no statistically significant difference. Now, Kruskal-Wallis Ash test, which is also known as one-way ANOVA on ranks, and it is non-parametric you can say substitute for the ANOVA, one-way ANOVA, and a rank-based non-parametric test that can be used to determine if there are statistically significant differences between two or more groups. For example, there are 4 or 5 groups in your study and you want to compare them. So for that, you cannot use Mann-Whitney-U test because it only compares 2 groups. So for that, you can use Kruskal-Wallis. And it is considered non-parametric alternative to the one-way ANOVA and an extension of the Mann-Whitney-U test to allow the comparison of more than 2 independent groups. So what are the assumptions? Number 1 is that dependent variable should be measured at ordinal or continuous. Assumption number 2, independent variable should consist of 2 or more categorical independent groups. And assumption number 3, it should have independence of observations, just like Mann-Whitney-U, but there was no independence observations required in the Kruskal-Wallis. Assumption number 4, if your distributions have the same shape, so you can use SP as statistical or Kruskal-Wallis test. So the distribution should have the same shape for all the groups. So if you want to apply the Kruskal-Wallis test, go to the non-parametric test, click on the legacy dialogues and click on the K independent samples. This will give you this window. Click on the continuous or ordinal variable and put it in the test variable as it would be the dependent variable, and put the independent variable or the categorical variable in the drug treatment group and define range. And if there are, let's say, 6 groups, then click on 1 and 6. As in this example, we have 3 groups, so we have minimum 1 and maximum 3. But if you remember the Mann-Whitney, there was only 1 and 2. So this is how the outcome window will give you the results for a Kruskal-Wallis test. So here we have the main rank values on which the data is analyzed. So as we can see, there is difference between them, and the p-value is 0.014, which is less than 0.05, which means that there's a significant difference between drug A, drug B, and drug C in this example. So that's all about Kruskal-Wallis test and the non-parametric test of significance. I hope you learned something new out of it, and keep on watching sqadia.com for more lectures like this. Thank you very much.